Good morning, friends. Welcome to the Science Show. And the biggest question that we ask ourselves every day is that are we alone? More importantly, if we are, a species which is important, and universe has very few species like us who can think about stars and galaxies. So where these intelligent species other than humans will live on? So are there planets similar to ours? I think that is the biggest question that we have to ask. And this is exactly what the scientists have recently found, as the topic of this live stream suggests, that the scientists have been able to detect very close by a debris of ancient planets. And how this system looks like, that is what the topic of our discussion. And since we are live, you can actually watch this live stream, reach out to me with your questions and suggestions, and share your thoughts on this very very thought provoking subject. And it also tells us about our state, our position in the entire universe. So the scientists have recently been able to detect another system very close by, which is estimated to be about 10 billion years old, at least 10 billion years old, or it could be even older than that. And the reason for this, we are discussing this system today, is simply because this system shows the debris field of the ancient planets. Now, we know that the sun was born 5 billion years ago, and most of the planets in our own solar systems are at least 4.5 billion years old. Whereas, as compared to this solar system that we see in the close vicinity in our own galaxy, has been dead for 10 billion years ago. So that means if the solar system, this particular solar system, died 10 billion years ago, that means it would have formed soon after the Big Bang. It could be one of the early solar systems. And since this is around a white dwarf, that makes it even more interesting, because white dwarf is something which our sun would become after 5 billion years. That means the life of this kind of a solar system is about roughly 10 billion years. And now this solar system is showing debris field of ancient planets revolving around a white dwarf. That means this solar system would have been very similar to our own solar system, and now it is dead. The planets are broken apart, and in the middle, instead of a star, there is a white dwarf star. So in order to understand and carry forward this discussion, let's understand how the similarities, and what are the similarities between this white dwarf and our own sun. Well, the sun, as you know, is a very big object, and many times heavier than Earth, and many times bigger than Earth. In fact, the sun contains 99.8% material of the entire system. So if you take the weight of the solar system, you would find that the sun has 99.8% of the material which is inside the sun. Rest of the other material which is floating around in the solar system is comprised of only 0.2%. So you can imagine the size of the sun, it's pretty big. But moment this kind of stars are formed, which are the mediocre stars, and these are called yellow stars, yellow mediocre stars, the death nail is already is inserted moment these type of stars are born, because these type of stars will have a known lifespan. We know that these type of stars live for approximately 10 billion years, and it is because of the dance of power between the kinetic energy which is being generated at the core of the star, and the gravity which is trying to crush the star further. So it keeps balancing for about 10 billion years, but after 10 billion years, the the kinetic energy reduces because the star runs out of fuel, and it stops generating billions of degrees of temperature in the core, and because of that the gravity takes over. When the gravity takes over, the entire star starts to collapse as the gravity is trying to crush the material, and the resultant body that is formed after that is basically called white dwarf. Why it becomes a white dwarf? Because of the electron pressure. See, all this while when the star was shining, the heat from the core of the star was able to balance the star till the time the heat was being generated. But now the heat engine is stopped, and since there is no heat which is expanding the star, trying to expand the star outward, the gravity actually crushes it down to the point where the electron itself starts supporting the force of the gravity, the immense gravity. So the white dwarf is an object which is in size very similar to the size of Earth, but it has a mass of the sun. It has mass, it's quite heavy, very dense, and it is not as hot as a star, but still has the temperature few times lesser than the star initially it was. So it is actually sort of colder body as compared to a normal star, but yet a freshly born white dwarf which is completely balanced by the electron field. The gravity is not sufficient to crush it further, and the electron field start to balance it out, and yet there will be no reaction, there will be no thermonuclear reaction or any heat generation which a star is going to generate anymore. The gravity will be completely balanced because of the electron pressure from within the star, but there is no reaction going on. So there is only one fate which now remains for white dwarf, if it is not disturbed, is to gradually cool down. So we know based on our observation that a freshly brewed white dwarf has a surface temperature of 150,000 Kelvin, which is, if you compare the temperature of the core of a star, which runs into millions of degrees. So it is 150,000 Kelvin, which is not as hot as the typical star when the star was alive. So the starting temperature is the 150,000 Kelvin, which is not very hot, but it is the remnant heat of the previously yellow star, and now it has only one destination, which is to radiate this energy into the space, and gradually it will start cooling down. And so far we have seen that there are colder white dwarfs also, and the temperature can go down to as cold as 4,000 Kelvin, which is similar to the surface of the sun today. So anything colder than this will be really old white dwarfs. So that is how we know, we can actually measure the age of these white dwarfs that keep floating around, and these are the dead corpses of the category of the yellow stars will become the white dwarf, and there are many white dwarfs that we see floating around in the galaxies. But there is more to this body, and that is the configuration of the white dwarf. You see, the yellow stars, even though they are very big, I mean, if you look at our size and the sun seems to be very big, but it does not have enough punch to create much more heavier element. So essentially, in the entire life of the sun of 10 billion, the heaviest metal the sun will produce, or heaviest element the sun will produce, is carbon. And after that, it does not have enough energy to produce even heavier elements. The bigger the star, more elements are produced in the core, or the element creation factory, which is the core. So in sun type star, which eventually becomes a white dwarf, the core of the white dwarf usually consists of a lot of carbon. And the carbon, when the carbons are arranged very neatly and very closely together, they are actually they create a tetrahedral compound, a sort of a combination of only carbon atoms, and this is the configuration of a diamond. So essentially, a white dwarf is a very hot, very large, Earth-sized single-piece diamond where all the carbon atoms are connected to each other in a tetrahedral format, and that becomes the core of the white dwarf. And then there is leftover helium, which has one layer, thin layer, and then there is a leftover hydrogen which is still there, and that makes the configuration of the white dwarf. And then this is kind of not generating any heat because there is no reaction going on in the core of the white dwarf, and it has only one destination, which is lose out that heat which it has generated for so many years. And because of that, it will just keep dropping in temperature, and initially it will be white dwarf, then it will become black dwarf after trillions of years. If it is not disturbed, this is how the end of the white dwarf would be. It will completely cool down, and once it is completely cooled down after trillions of years from now, then they will be essentially called a big ball of diamond. So this is a typical white dwarf. And recently, the whole we're talking about this solar system which we have found, and all of these bodies which are floating around in the solar system around a white dwarf has a temperature of 3000 Kelvin. And the name of this, or the catalog name of this particular body, is called WDJ 2147-4035. Now this white dwarf, we know based on our observation that the white dwarf can cool down, but this one is probably the coolest white dwarf we have noticed so far. That means this white dwarf is at least 10 billion years old. That means this white dwarf was formed 10 billion years ago, and we know that the universe was formed 13.8 billion years ago. So I think this is one of the early yellow star and the solar system which perished now, and it exists in our own galaxy with the remnants of the planets which the original star had. And you know that planets will have a lot of metals like iron, etc., and even heavier elements, because that's what planets are made of, whereas a central star will have predominantly hydrogen and helium, and it keeps making heavier element until it touches carbon, and that's when it becomes white dwarf. So we have seen this particular object which is very similar to sun, but it is older. That means this solar system and the star died 5 billion years before the sun was even formed. And therefore this is very exciting, because we know that this particular star system has a white dwarf which has very low temperature as compared to other white dwarf. That means it must be older. It has dissipated most of the energy into space, and this is even becoming cooler. And at this point in time, as per our calculation, the surface temperature of this white dwarf is 3000 Kelvin. And it also shows existence of broken rock which are floating around this white dwarf. And these are the remnant of the planets which were revolving around this star when it was alive. So I think this is something which is very exciting, and if you want to basically go further on this, I think more study will be required. And because this study is required simply because to understand what will happen to our own solar system after 5 billion years. So I think this is a very good example which is close by within our galaxy that we can study and make a lot of assessment of what is going to happen to our planets, our sun, and other objects which are present in the solar system. And that is why this whole study is very exciting. And it also proves that there was a time when the yellow star type solar systems were formed very early, soon after the Big Bang, because we know that the life of a yellow star is 10 billion years. And if this one is dead for last 5 billion years, that means it would have formed soon after the Big Bang, and it would have died very quickly. And it has been dead at least 5 billion years. So I think this offers a very good opportunity for humans to study this in a more detailed fashion and come up with hypotheses about our own solar system. So friends, are you excited to learn about this information? Please share your thoughts and comments. Any questions, I will be more than eager to answer you. So as always, thanks for watching, and I will catch you in the next edition of Science Show.